very good morning to Dr. Asno. My name is Shaun Yap Jian Aun.
My name is Izzah Hidayah.
We are from Group 8 and we would like to present to you about cruise control system for our course, Industrial Control EEE3402. Firstly, let me introduce to you what is cruise control system. Cruise control system is used in any vehicles that support it, and it allows the driver to maintain the speed of a vehicle without applying pressure to the accelerator pedal. If you see here from this block diagram, cruise control system contains three simple components, which is the speed sensor, the electrical control unit, and also the speed control. Later, these components will be discussed further by my friend Hidayah, who will talk about it more soon. Now I'll pass the time to Hidayah.
Thank you, Shaun. Okay, first I would like to explain about the system operation, which consists of throttle actuator unit and electronic control unit. Okay, first I'll talk about the vacuum operated diaphragm controlled by two simple valves, which is in this explanation will be defined as valve X and valve Y. Okay, from this figure you can see that this one is valve X, this one here is valve Y, and another valve for safety is called valve Z. Okay, firstly, valve X is opened to increase the speed, and then low pressure here, low pressure from the inlet manifold comes in contact with one side of the diaphragm. Atmospheric pressure on the other side forces the diaphragm and hence moves the throttle here. Okay. And then when valve X is closed, valve Y is open, here valve Y, and then the throttle moves in reverse direction. Atmospheric pressure enters the chamber here, and then to the fan here, and then the spring moves the diaphragm back. Throttle position is held when both valves are closed. When both valve X and valve Y are closed, and then only the throttle position is held. And then the cruise must not remain engaged, and the manifold vacuum is not disturbed. Thus, valve X must be closed and valve Y opened so as to be prepared when electrical failure occurs. Then here, valve Z, the safety valve, is controlled by the brake and clutch pedals in order to ensure safety. Just like in car, when we want to stop a car, a manual car, we have to press the brake and the clutch. So valve Z act as a clutch and brake in the car. Okay, next, the second system operation is the electronic control unit (ECU), which is the main control unit. And then what it does is it finds out the vehicle operating parameters before it starts to operate, because this is an automated system, so it needs to find the parameters first and then sends out signals to the throttle actuator to regulate the throttle valve position. Cruise control system work on the proportional integral control technique. Okay, we have proportional control, proportional integral, and proportional integral differential. Is it? Okay. And then a derivative. And then this cruise control system only use PI control, which is proportional integral control. Okay. The road speed signal that is consistently sampled by the microprocessor, and the road speed signal consistently sampled by the microprocessor, which means that the microprocessor will consistently record how the cruise system move, the speed of the move system, and then when a difference is detected, the proportional integral control generates drive pulses in order to make the responding variable zero difference with the set point. And then the pump and valve quickly restore the set speed without overshoot or oscillation. Integral control is included when the system is not done correctly, or in other words, when the integral control system is overdamped. And then the final signal is the sum of proportional and integral control signals. Okay, so the summary of this system can be further detailed, further explained by this one. Okay, the block diagram. So before I proceed with the block diagram, so let me define variables of the system first, which is responding variable is the speed of the cruise. So in this system, we want to control the speed of the cruise. Then manipulated variable is the throttle position, which is the throttle actuator unit that I explained earlier. And then the control variable is the throttle actuator switch. Okay, from this block diagram, you can see that first, sampling switch is the control variable from speed sensor, and then this is the switch. Okay, command speed is the set point set by the user, and then this one is the vehicle speed, which is the responding variable that will be compared. These two will be compared: the command speed and the vehicle speed. So then if the difference is detected, then only proportional and integral control will act. And then this one, look up proportional gain and integrator for integral gain. So this is the control system, which is PI that I mentioned earlier. And then the difference or the result from these two will be added, and then there will be an output control, so that the speed of the cruise system is maintained. Okay, so next, Shaun will explain about the ladder logic diagram.
Now I would like to explain a bit about the ladder logic behind the cruise control system. So basically in the ladder logic diagram, there are 4 different parts which can be divided by observing the comments on top of each rung. So firstly, we will talk about the requirement of the drive mode. Secondly, we'll talk about the requirement of the minimum speed. Thirdly, we'll talk about how to turn on the cruise control. And finally, we'll determine the speed of the cruise control. So firstly, the first rung, we can see that there are 2 contacts here. Firstly, D and first and second. These contacts, they represent the drive gear of the car, whether in drive or in first or second gear. We can see that if drive is energized, then the rung is energized and the relay drive is also energized. So we see that if the car is in drive, then cruise control can be enabled. But if first and second gear is used, the contact is energized and it opens, and it does not allow drive to be energized. Secondly, we'll look about the requirement of the minimum speed. We can see here there are 2 contacts used, the minimum above the minimum speed and below the minimum speed. So we see that if the car is above the minimum speed, the contact is energized and the rung is energized, which energizes this cruise enable relay. So these 2 requirements, drive and cruise enable, are needed to turn on cruise. Thirdly, we look at the third part. We'll see that cruise enable and cruise on needs to be turned on for cruise to take place. So we can see cruise enable is the relay that is right here. Okay, cruise on is actually a button that needs to be pressed if we want to turn on cruise. Resume is another button that we can press if cruise has been disabled temporarily but wants to be resumed. And finally, we can see that brake is a normally closed contact that, if energized, will break the circuit and will de-energize the vacuum pump and throttle actuator, which is used for cruise control. Finally, the last part is the speed determination for the cruise control. We can see that this button set is the button that needs to be pressed to turn on cruise as well as to determine the speed. We can see that a clock is used for 1 second to determine that the minimum amount of time needed to determine the speed is 1 second. We can see that a counter is used to determine which speed the driver wants to use for cruise. In this example, we have chosen 3 speeds, which is 70 km per hour, 80 km per hour, and 90 km per hour. Next, I'll show you a simulation to help you understand this ladder logic diagram. Alright, so this is the simulation of the program. So firstly, we can see that there are a few conditions that need to be set. Above minimum speed, below minimum speed, set, brake, drive, first and second, and resume. So, to enable cruise control, firstly, we must enable the drive gear. So drive relay is enabled. Secondly, we must make sure that the car is above the minimum speed. So cruise is enabled. Now finally, then we can set cruise to enable by pressing the set button. Alright, so cruise is enabled, thus enabling the vacuum pump and throttle actuator to regulate the speed of the car. We can see that if we want to stop cruise, we can either press brake, and this will stop cruise. Another way to disable cruise is also by disabling one of the requirements of cruise, which either is the first and second gear, which disable cruises, or we can also press the minimum speed to show that the car is below the minimum speed required for cruise. We can see that if we want to change the speed of cruise, we need to long press set, which will cycle between the three speeds available for cruise control, 70, 80 and 90 kilometers per hour. If we brake, cruise will be disabled, and if we want to resume, we can click resume and cruise will be enabled. So this is the simulation of the ladder logic diagram, and we hope that you have gathered some knowledge about cruise control. We thank you for your patience and time. Thank you, Dr. Asno. That's all from us.